Snavi, how are you?
I'm good, thank you, Michael. How are you?
I'm very good, thank you. So, thank you for taking the time to show us one of your workflows. Would you kindly tell us what do we see here?
Yeah.
What is this machine?
Okay, so this is a five-axis generative machine. It has motions in the XYZ direction. So you can see it, the nozzle can move around this, and the Y axis, and also it can tilt and rotate along the bed. So this is like a five-axis gantry system, which is a small desktop printer.
Mm-hmm.
So what we are slicing today is a two-node pipe, which looks like this.
Mm-hmm.
So what would be the complex parts here is the jumps when we are printing on both the sides. So I've created a workflow. So to simplify how the movements of the machine and the slicing will be, I'll quickly show you how you can move ahead with this.
Yeah.
So what we first do is we import the object file, and
Mm-hmm.
then we slice it. So in slicing, AI Build has slicing modes, which gives you the freedom of choosing any slicing mode which is close to your geometry.
Mm-hmm.
As you can see here, the closest one we can see is the segmented. So choose it. We can choose the meshing resolution of the object.
Mm-hmm.
Then we give the software with what layer height we want, what would be the slicing from the bed plane, the mesh minimum Z. So these are some of the options which gives you the complete freedom of how you want to slice the object.
Mm-hmm.
And then also slicing mode has how we compute our geometry and the slicing. So this is maximum, minimum, and average layer height, which you can see
What
from
what
the.
is what does that mean, Vaishnavi?
So
Uh,
what it does is the slicing, so the polylines that we see will be, the logic used to slice them will be based on what the average layer height you want it to be.
okay.
So as you
Okay.
can see in the diagram, so if it is varied, like on the left, you see the layer height is more and on the right, it's less. So we can clearly see it
So
on.
when I select the segmented, this is basically an automatic, it understands the geometry. It
Exactly.
creates a toolpath that is non-planar, so
Yeah.
it goes up and down.
Yeah.
And then I can control my layer height to be within a range according if I want to control the minimum or the maximum or be in between an average.
Exactly.
Okay.
So this is like a good setting to go ahead with when it's a non-planar geometry. So
Mm,
right now we have chosen average layer height, and we given also the layer thickness we want. So we have a completely sliced model, but
mm.
as you can see here in the sequence, so you have visibility options here. I see that there are jumps, so it's not like the slicing is happening in one direction, right? So
Yeah,
sometimes,
otherwise it would always the red will have been into one branch, right?
exactly.
Yeah.
So sometimes we want that, sometimes we want to reduce the jumps we want. So
Hmm.
what I am doing next is I'm filtering it by layers.
Okay.
So what I mean by that is I am going to filter the first segment out, because from year to year it's
Hmm.
like one section, and what we see next is two branches coming out, as you
Yes.
see here.
Yes.
So the reason I'm doing this is I want to separate the segments out so I can spiral them individually and
Mm,
reduce jumps.
okay. Yeah. Makes sense.
Yeah,
Makes sense. So then you spiral the filter out, which is the bottom, and then you are sorting, so it's back to.
yeah.
Okay.
So by
So now
spiral,
it's blue because I don't
mhm,
have layers.
exactly.
The sequence is. yeah, it's just one
Yes,
continuous
and the
project.
reason for spiral is here you can see I have seams. So every
Mm-hmm.
time it does one layer, it will jump out, jump in, and
Mm-hmm.
then do the next layer. But what we can do with spiral is now you see it's just one seam, and I don't have to make the machine jump back and forth, and it will go round and round without pausing. So that helps with the time of the print, and also with not showing where the seams are, which you usually see on the prints. So
Yeah.
this is a very good setting that we have. Next, we go on to sort by proximity. So another very powerful setting we have in the software is sort. What
Mm-hmm.
it basically does is right now it's sorted it on its own. Like I start from here, end it here, and then I'll jump here, start from here and end it here. So
Mm-hmm.
this kind of makes the entire machine understand that there are two different ways we can do it. So I don't have to come here, then here. It basically understands the logic of sorting, and it again gives you a complete freedom of how I want to sort. So these are um, number
Yeah.
of techniques I could sort in, but the best fit one right here is sorting by proximity.
Mm-hmm.
And
Especially if you have like 10 branches, it would be even more complex.
exactly. So it
Mm.
will identify each branch individually, and you don't have to manually decide for each polyline. So it
Mm.
automatically does it. And then we use spiral to then spiralize each side, so we don't have many um seams. So it's just
Mhm.
like one spiral, and it will take you through the entire segment. And then we combine all our three segments. So
Mhm.
combining is another very powerful setting that we have, wherein we can feed in the data, we can remap. So here we see that the sequence is 0 to 2. So it's
Yeah.
starting from the base, doing the second, and then the third. So
Yeah.
it gives, you don't have to individually tell it, okay, first we need to go from here to here, and then uh, it
Yeah.
automatically detects it for you.
Mhm.
Then we attach our toolpath. So in Toolpath, we see the simulation of how the slicing is going to be. Since we have like this 5-axis printer, we have the liberty of moving or rotating or tilting the bed. So in Toolpath, we have the setting of how we want the printing bed to be. So again, this has different settings which I could use, and it could help me in deciding what my simulation would look like. So
Mm.
here we see it's inactive one axis joint. By one axis joint, I mean that I could only rotate this bed. The next one would be a two-axis joint where I
Yeah.
could only tilt the bed, and so on and so forth. So we also have revolve when we
Mhm.
have geometries which are asymmetrical. We can use keep tool vertical, so it automatically determines if the geometry needs a tilting or it needs like rotating. So you
Mm.
don't have to control it individually. Right
Yeah.
now we are using just one axis joint.
Mm.
So yeah, so the simulation is ready for us. This is
Mhm.
how our system is looking.
Let's have a
So
look.
yeah, so if I start, we are doing the first segment here,
Yeah. Yeah.
which
Yeah.
automatically you see these motions. It's our
Yes. Yeah.
like it's taken care of.
Yeah.
And when we rotate it,
And we
and
do
it's
one branch and then the other branch. Yeah.
yeah. So this is how smoothly we can just create
Yeah.
this two-node pipe.
And
Uh,
Vaishnavi, I know, so because always there is a collision
mhm.
worry between branch one and branch two, especially in the movement, right?
Yeah,
We have functionality that we can say to the toolpath jump, right?
exactly.
Where is
Mhm.
that happening into the jumps? Okay.
Yeah, so in jumps, we again have a settings which we can minutely control how we want the jumps to be,
Mm.
how we want the end of the polyline, if we want to deposit some material and then move on to the second segment. So we can see that here
Mhm.
we have deposition before start if we want to wait after the open polyline.
Mhm.
In filament printers like this one, we also have an enable retraction wherein it
Mhm.
pulls in the filament back. So if I want, if it's like a lot of jumps I have, I could uh, activate this enable
Mhm.
retraction, and then it will help me to like not, you know, you see stringing, so we can
Yes, yes,
avoid
yes,
that.
yes, yes. Okay.
So this is another cool things. And then we have jumps with what jump we want. It could be linear, it could be arc, and if you don't want it, you can just disable it.
Mm.
But to be safe and not to and to avoid collision between the prints, we usually go on with linear jumps.
Yeah,
So that is how you can avoid jumping and collisions.
very cool. Oh, that was great, Vaishnavi, and very fast. Is a very cool workflow. I think you have it already printed, this one, right?
Yeah, I sort of have like a prototype
No.
which I'm testing with, and I'm just trying to see how I can make it more seamless and add more branches.
Mm,
So yeah, this is like a fun project to
very
understand
cool.
how we can slice with different and difficult geometries. So very cool to use
Yeah.
the
Oh, thank you,
software.
Vaishnavi. That was awesome. Thank you very much.
Thank
Let's
you,
do
Michael.
let's do more of those. The community, I'm sure, will appreciate. Thank you very
Yes.
much.
Thank you, Michael.